Hi everyone, today we're going to talk about data cleaning, and within that we're going to go over what it is and why we do data cleaning and why is it so important. And as well as that, we're going to go through a few different examples of how to enter your data and how to clean it. So data cleaning sounds like a very strange concept, but essentially it is the process of finding, correcting, or removing data from a database that is either complete, incomplete, incorrect, formatted wrongly, duplicated, or imprecise. And so essentially what data cleaning does is it will hopefully result in a database that is correct and that we can use for analysis. So the reasons why we do data cleaning is so that our data is reliable and valid, and we want to have a high quality of data. By having clean data, we can prevent further difficulties in analysis later on, and it also feeds into the concept of research integrity. So by having clean data, then we can prevent the potential for misleading results, and from that having incorrect conclusions from our data. So if our data is wrong, then our results will be potentially wrong. So essentially any junk that you have in, you're going to get junk out at the other end. And so we don't want to have you collecting data for perhaps months or even years and then getting a result that perhaps isn't even correct. So before we even look at a database, we should be considering outlining what variables we want to record. And what helps us to do that is what we call a codebook or a data dictionary. And it helps you to be able to explain what your data is. And other people can then have a look at your data and compare it to your codebook to know what is going on exactly. So your codebook indicates what each variable means, what values they take. For example, male might be recorded as a 1 and female as 2, so we know what the 1s and 2s then mean, and also how each missing value is coded. A data dictionary should be written on a separate sheet within your data, so that could be in a separate Excel worksheet or in a Word document. And when cleaning, you should essentially copy your data onto another sheet and then use your code book to help you clean. And the reason why we copy our data to another sheet is so that if you make changes, that if they are potentially a mistake, then you're not going to overwrite your original data. And so as you go along, you can highlight or colour any mistakes that you find so that you can follow them up later. So this is an example of a code book. And so in this second column here, we have what each of our variable names are. So we have patient ID, procedure, survival underscore time, age, gender, NO, prior heart conditions, kidney disease. But along with all these variable names, we want to exactly know what they are. So for example, age. Is that age at diagnosis? Is that age at death? In this example, we can see that it's age at surgery. So essentially, this label column will tell us exactly what all our variables are. So as an example, kidney disease, we can see whether the patient had kidney disease or not. Now, in the next column along, this is very important for people to be able to understand the values in your data set. So these are the values that all your different variables can take. So for example, for your patient ID, it says here that we have a study with 30 patients in total, so we shouldn't see any more than 30 people in our data set. For procedure, or procedure type, sorry, that the values in our data set will be 1s and 2s. And what 1 means is angioplasty and 2 means bypass. And so the reason why we want to put in numbers instead of the actual word angioplasty or bypass is because when different people enter the data, they might enter angioplasty with different spellings or with different capitalization, and when we go to analyze that using a statistical program, it is case sensitive and it will treat every different spelling as a different value. So putting in numbers gets around that issue. So for survival time, it's the length of survival since surgery. It's measured in years, and the maximum number of years that we've followed people up for is 5 years. The age at surgery is measured also in years, but in our study we had an exclusion criteria of greater than 90 years. Gender was recorded as M as male, F as female. Number of prior heart conditions is a whole numbers going from 0, 1, 2 and so on. And here you can see that we have a 999. And often you'll find that people will write that in for missing values or unknown values, and it should be a value that this particular variable cannot take. And so what that allows us to do, if you want to record several different types of unknowns for different reasons that people are missing, for example, you can include 777, 888, 999 and so on and so forth. For kidney disease, whether they had kidney disease, it was recorded as a yes, no or 999 as unknown. So when we go to enter our data, we can have a few things in place to be able to help us enter the data correctly from the get-go. So there's 2 possible tools called validation and conditional formatting. So let's run through an example now. So here we have the different variables that we just spoke about before. And so for our patient IDs, we might have patients 1, 2, 3, 4, 5, 6, so on and so forth, down to patient 30. And we want to make sure that when we put the data in, that we don't put it in with any mistakes that will be difficult to follow on months or years down the track. So one way to do this is to use data validation. So if we want to make sure the procedure type that we put in are only 1s and 2s, so 1 meaning angioplasty and 2 meaning bypass, then we can go to data after we select our cells that we want to apply it to, of course. Data validation. And then we set the rules for what values can go in these cells. So we only want 1s and 2s. So we want whole numbers. And our data, we want it to be between 1 and 2. So click OK. And so when we enter, just say patient 1 has a procedure 1, patient 2 has procedure 2, patient 3 has another procedure 2, but just say we accidentally put in the number 6. So it will come up with an error message and saying that the value we've entered here, this number 6, is not valid. So it warns us, and so if we go back and check what the proper value should be, just say it should be a 1, then we can carry on with entering our data correctly. Okay, so you can do the same thing with all of these other variables. Another example is for, just say, with kidney disease. So kidney disease was recorded as yes or no. So if we go to data validation again, we want to select a list of values. Okay, so the list we want to make is yes, no, and also remember 999 because that was indicating the missing values. So click OK. And what you'll notice is there's a little down arrow here on the right. So if we want to enter for patient 1 what their value was, just so they had kidney disease, then we can click on yes. If we want to enter it straight in, we can do that as well for patient 2. Just say we want to enter in don't know. It again will come up with an error because that's not in the set of values that it should take. So that way you know that all your text that you put in here will be correct. The other way to make sure you put in correct data is to do what we call conditional formatting. And so similarly, we highlight the cells that we want to apply our conditional formatting to. Go back to home, click on conditional formatting, highlight cell rules, and so for survival time we only recorded it up to 5 years. So we shouldn't see anyone greater than 5 years survival. So we want to click on greater than. And so we only want to highlight the cells here that are greater than 5 years. And it will fill it with a certain color here. Click OK. And then when you enter your data, say for patient 1, 3 years, patient 2 was 2 years, patient 3 was 5 years, that's still okay, but if someone was 8 years, then it will highlight that cell and tell you that there's something wrong going on that you need to go back and check before you enter that data. So there's a couple of ways to help you with the data entry. Notice when you enter your data that all the variables are written in the column in the first row, and all information pertaining to each individual patient who should be unique in their identifier, all that information is contained in that one row. Okay, so we'll move on. So once you've actually collected your data, what do you do to check that it's correct now? And so again, as before, always copy your worksheet to check. You don't want to overwrite your original. The thing I didn't mention before was that your variable names across the top shouldn't have spaces in between the wordings because a lot of statistical packages are unable to read them in. And again, each row should be unique. So let's have a look at another example. So here we have our data set. On the surface level, it looks pretty nice. We've got our different variables measured, one for each column, and all of our patients are measured in the rows. So let's have a go at data cleaning. So first, let's check whether there are any duplicates. So each of our patients, there should only be one row for each patient. So let's highlight these patient IDs, and we can use our conditional formatting again to check for duplicates. So conditional formatting, highlight cell rules, duplicate values, and click OK. And here we go, we've got 2 patient IDs with a value of 21. So it's highlighted those. So you can go back and check whether that's just a typo or you've accidentally included the same patient twice. The other useful tip to help with data cleaning is called filters. And so let's go through an example of that. If you click on sort and filter, you'll notice these little down arrows appear at the top. And so what is in these down arrows is all the values that your data has taken for that particular column. And so for the procedure type, if you remember back to our code book, which you can see down here, is in our second tab of Excel. You can see here that the values take 0, 1 and 2, but in that code book it said that they should only be 1 or 2. So let's find that one that's a 0. So deselect all, click on the 0, and we found that person that was assigned procedure 0. So click on him and we can highlight him to check up later. We want to take that filter back off so we can keep checking the rest of the data. So we can do the same thing with survival time. So we only expect survival time up into 5 years. So there's one at 20 years. So deselect all, click on the 20, and that just brings up the one that's 20 years survival time. Let's highlight that one too for checking. And then select them all again. So you can keep on going with that through all the different values there, all the different variables there. The other way to do a checking as well is to use Excel formulas. And so, for example, we'll go down. We want to check whether the range of values that age takes are correct. So we can look at the minimum age. So we've got equals min for minimum, open brackets, highlight all the cells you want to check for age, close brackets, and the minimum age was 56, which is reasonable for our data set. If we want to check the maximum, we can do that too. So equals max, open brackets, highlight the cells you want to check, close brackets, enter, and the maximum value is 999. We can also do the mean or average, so equals mean, equals average, open brackets, highlight your cells, close brackets, and you can also do standard deviation, STDEV, open brackets, highlight your cells. So this minimum here looks reasonable for minimum age. The maximum age is 999, which if we look at our code book, looking at the age, it's measured in years, exclusion criteria is greater than 90 years, and there's no mention of a 999 being unknown. So we need to flag that 999 value because it's actually not in our code book, and we need to question, well, maybe the 999 was meant to be in the code book as well. So that's another way of checking, but the only problem with that is it only flags the two, the lowest and the highest value. So if there is another value that shouldn't be, that is too high for your data code book, then it won't show that value. Now with the mean, we have a mean age of 102, which is extremely high, and it's higher than the exclusion criteria of 90. So it's showing us that there's something wrong in our data column here. this standard deviation of 170 is incredibly large, also showing that there's something wrong. And so these two practically reflect that this 999 value was in the data set. So let's flag that 999. So we can go to our filter, deselect all, click on the 999, and we'll highlight that one. But we'll have to also check that filter for any other strange values. So if you look down here, there's an age of 91, which is greater than the exclusion criteria of 90 years old. So that one also needs to be checked. Now for gender, it works a little bit different to numeric data here that we've looked at. We can check our filter, and so we've got an F, an FM, and an M. So that FM looks a bit wrong, so let's check that one up. But the thing that you will notice is that these filters don't show the different cases, so whether it's uppercase or lowercase. And so given that statistical programs are case sensitive, and it will consider a capital M as different to a lowercase m, we need to flag those ones as well. And unfortunately, I haven't found a way to flag this yet in Excel, so you might have to go through the data individually, or as I said before, in your codebook, saying that you record the F's and M's as ones or twos or zeros or ones, whatever number you want to assign it. So here we'll go through it manually. So we'll flag that capital M because it should be a lowercase. And as you can see, it's quite difficult to find them. There we go, there's another one. So the other way to get around it is if you create another variable and change them all to the same case using the Excel function, equals upper or equals lower. So we can go equals lower of that particular cell value, close brackets. It'll come up with the lowercase f, drag it down for all of them, and so that capital F has now been changed to a lowercase f, and that's how you record that variable. So we'll keep going through the rest of the data set using the filters. So click on the filter. So number of prior heart conditions, there was no restrictions on how many we could have, but 10 does seem a bit extreme for one person to have. So we should flag that one anyway and just check that that's put in correctly, because perhaps that could be a 0 or a 1. Someone accidentally added it to double digits. And then for kidney disease, we'll do the same thing as the gender. So we'll check that. They all seem right. There's only lowercase no's, lowercase yeses according to the filter. But as we can see, if we go through it and use our eyes, that there's a capital NO. So let's flag that one. Another capital NO there. Capital YES. And there perhaps is another one in there, but there we go, there's another one. Okay, but you can see that's quite prone to errors, so it's better to use your lower and upper Excel functions, depending on how your codebook says it should be recorded. Okay, so on to the next example. Okay, so as we've discussed, stats packages are case sensitive. You can check your values against your codebook using the Excel functions or filters, but I didn't also mention that you could use your conditional formatting as well. And the last thing we didn't discuss about in that example are about dates, and that's a particular special case to consider when you look at data cleaning. And so just keep in mind before we look at the next data set that our date value should be recorded with a /, not a dot between your days, months and years. So let's look at the next example. Okay, so we've got our code book. This is the first thing we'll look at. So we've got DOB is our variable name, which is date of birth, measured as day dot month dot year. Sex, capital M, capital F for male and female. BWT, weight at birth in grams. Gestational age in weeks. CONG, which is congenital malformation, and that was given the values of 1 equals none, 2 is non-life threatening, 3 is life threatening. High O2, meaning max oxygen percent received. LOO2, minimum oxygen percent received. Mortality, recorded as 1 as a patient death, and 0 as the patient did not die. And death underscore DA is the date of death, measured as day, month, year. So let's look at our data. Now let's apply those data skills that we've already obtained and apply those filters. So go to the top right, sort and filter, and we've got our little down arrows at the top now. And so if you click on that, you can see all the dates recorded. It records it in order of lowest to highest, and all those dates seem reasonable according to this data set. If we want to check sex, click on the down arrow. We've got another FM there, so I'll just click on that right now, highlight him to check. But we should also check that the fact that of the capital M's and the small case M's, so how was it meant to be recorded? Let's check in our code book, capital M and capital F. So we'll flag the lowercase values, and they need to be changed to uppercase. Okay, if we wanted to use our conditional formatting, we can highlight those cells, click on conditional formatting, and just say we want to check values less than, say, 500, because maybe perhaps in this case birth weights lower than 500 is very unlikely. So click OK, and there we go. We've got a value of 290, which is extremely low. So we've highlighted that to check, but we can also use our filters to check as well. So the 290 is the lowest, perhaps 740 is okay, 1300 seems reasonable. So let's keep going with our filters, check the gestational ages. 2.91 is very low for a gestational age, so let's flag that one to check, because it is likely wrong. And we'll check the highest values as well. So the 27 seems okay, and 34, 35 is okay as well. With our congenital malformations, we might want to check that having 5 congenital malformations is perhaps something that you wouldn't see often, or whether it is a typo. So let's flag that one to go back and check whether it is that you check back through the charts or however you get that information. And then this highest oxygen and lowest oxygen. So we expect the highest oxygen to be greater than 0, I would say. But given that it wasn't written in our code book, we don't know for sure. And so that kind of shows why a code book is so valuable. But just using our common sense, I would say a value of -80 is likely wrong. So click on that. Okay, and a 9.8 for the highest oxygen is extremely low. So let's click on that one too, highlight him. Oops, there we go. And then they all seem perhaps okay. So let's select them all again. And we'll do the same with the lowest. So 21 to 32, that seems okay. Mortality, it was meant to be recorded as 0 and 1. So 1 meaning death and 0 meaning did not die, that's okay. And the death dates, they seem reasonable on first glance. So what we've done is checking within each variable, but you can also check between variables. So you can use one variable to check another. And so we can do this in the case of this high oxygen and low oxygen. We expect the high oxygen percent to be higher than the low oxygen. So if we take the difference between these two values, so we go equals high oxygen minus low, we expect the value here to be a positive value, so greater than 0. So 14, that's good. If we drag this down to get the answer for all those, then we can see here that we've got a minus 103, which we've already flagged this minus 80 as being potentially wrong. And if we go down 34, 4, 99, 0, we expect there to be perhaps a positive value here. So perhaps there might be something wrong here, we don't know, we need to check that up. 15, 35, that's fine. Minus 12, well, we've already flagged that very low, high oxygen level. And there's another 0, so we'll flag those as well. And 38 seems fine. Now the other thing to also check is that those who died have a death date. So if we click on our filters, select those who didn't die, we'd expect that all of them didn't have a death date. Okay, because it filters out those ones that did. So that's fine, but if we click on those that did have a death date, that did die, sorry, then we'd expect all of them to have a death date. But this one here is missing. So perhaps we need to go back and check whether we have a death date for that one, or the question would be, perhaps this 1 should have been a 0. So we'll also flag that as well. So this patient might have not died. So let's select all of them again and go through how we work through with dates. So if we want to check that our death dates and our date of births are correct, we can do the date of death minus the date of birth, and we would expect that to be greater than 0. Okay, because you're not going to die before you were born. So if we go equals, now the thing is we have missing values here because these patients, well, they're not missing per se, but they didn't die, so they don't have a death date. So we need to put an if statement in. So we say equals if, open brackets, this particular cell is equal to empty value, put in a comma, then we want to make this cell an empty value, so we put in the double quotes. Else, so we put in a comma, we want this date minus this date, close brackets. Hit enter, and because we put in our if statement, it's showing a blank cell. But when we drag that down, it should come up with values for those that have death dates and date of births. But as you'll notice, we're getting error values. So what is going on here? Well, it's related to the fact of how we've recorded our, or how we've formatted our dates. So instead of having dots between the day, month and year, we need forward slashes. So let's change these. If we click Control F, then we can change it to replace. So we want to change all the dots with forward slashes. So we'll replace, and I'm apprehensive at clicking replace all because sometimes when you do that, it replaces something that you don't know about and didn't want to replace. So let's change these as well. So Control F, replace. So we want to replace that one. Oops. Find next. There we go. Okay, so they're all changed now. So as you'll notice, now we're getting some numbers over here with the difference between the death date and the date of birth. So here, the date of death was 7 days after the date of birth. And now we still have an error for this one. And this is related to the fact that if you look closer, this date is recorded not as day, day, month, month, year, 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 year. It's recorded as month, month, day, day. So we need them all in the same format to be able to do these calculations. So let's flag that one because we don't know whether it's just that one that's recorded incorrectly or whether it's all of these dates. So whether it was meant to be the 6th of the 4th instead of the 4th of the 6th. So, and then lastly, we can see that we've got a negative value. So this date of death was before the date of birth. So we need to flag that one as well. Okay, so that essentially concludes this data cleaning session. So if you want any more information, you can contact us on our website and all our contact details are there. Thanks a lot.